Chapter 1, Sample Question 2, another application of normal and shear stresses in an engineering problem. In this problem, we are talking about, working around to see what the design force is in an engineering problem. A load P, as shown, is supported by a steel pin. This is our steel pin, which is inserted in a wooden member. This is our wooden member, hanging from the ceiling. So let's say this is our ceiling. This is our steel pin, and this is wooden block. Ultimate strength of wood in tension is provided to be 60 megapascal, in shear 7.5 megapascal, and ultimate strength for a steel pin is 145 in shear. Some of the dimensions of the block are given. B is 40 millimeters, C is 55, diameter of the pin is 12 millimeters, and if the entire factor of safety for the entire system is supposed to be 3.2, what is the design force which applies to the pin? So to approach this problem, again, if for wood we have sigma tension of failure, sigma failure of 60 megapascal, shearing failure of 7.5 megapascal, and for a steel, tau f is shearing failure is 145 megapascal. You can by a single comparison, you can see how steel is far stronger than wood in shear, as well as a part of dimension which is B, C, diameter of the pin, and factor of safety. What is the we need to calculate the design P force. Let's break it to pieces to see how it goes. So first of all, based on double shear in pin. So if half of the force applied to this side of the pin and the other is applied to the other part, so that's double, absolutely almost absolutely double shear condition. So if you remember from double shear condition, so if there is a P applied, it goes to be half of that applies here, and so if you are going to calculate tau failure, it just gives P over 2 over area. It seems to be P over 2 area is equal to tau failure. Likewise in our problem, so if one want to calculate the force, it just goes by tau failure times 2 area. So likewise our problem is P failure based on double shear in pin, in our pin. It's a 2 times area times tau failure, which is 2 times pi d squared over 4 times tau failure of a steel pin. And if you just replace the numeric value, 2 pi times 12 millimeters, which is the diameter of the pin, in millimeters, it should goes by square. Mhm. Then times 2, yep, it, time 145 megapascal, and it just gives you 32.8 kilonewtons. If we call it equation 1, let's see what else do we have. This is one of the possibility for P failure, force of failure in this structure. Let's see what else can we have. So another situation which we can study that is a tension in wood. Tension in wood which applies to a net cross-sectional area. So what's that? That's if you can consider here. Mhm. So that's the area which uh, that's our a net cross-sectional area. And if we want to calculate that, that's nothing but the thickness, which is 40 millimeters from here, and the other part is B minus D. So that's A net is equal to B minus D times the thickness, which is again 40 minus 12 in parentheses times 40. Mhm. If we do so, it just gives 40 minus 12 millimeters, times again 40, which is this side. The thickness of the plate, 40 times 10 to negative 3 times the sigma failure for wood. Sigma fail for wood. Mhm. And if you do the calculation, it gives you the second possibility for P failure, which is 67.2 kilonewton. Let's see what else do we have. So we also have a double shear in wood, which applies to as the force P is applied, it just applies to this area on wood and one at the rear. And that area is nothing but a 40 times the length over here from here to here. So this is my cross-sectional area, one of them, and one at the back. So that's 40 times 55, two of them. So likewise, one can say that's P failure is 2 times area times tau failure for wood. So that's 2 times 42 millimeters times 55 millimeters, which we have here, times shear in wood, which is 7.5 megapascal. And the third possibility for failure is going to be 33 kN. And in a comprehensive approach, P failure is the minimum of all those three possibilities. So we had 32.8, 67.2, and 30 megapascal, and the minimum of them is 32.8. And if you remember from factor of safety concept, P design is acceptable or allowable force, which is failure or factor of safety. We are provided to have the entire system has a factor of safety of 3.2. So P failure is 3.2 kN over 3.2 factor of safety gives us 10.25 kilonewton, which is the design force.